Chen. She shared from and we'll just start with a quick introduction. So you go first.
Hey everyone. So my engineer with 7-Eleven. I worked extensively in the computer vision space for 7-Eleven and currently
Hello. Hi, I'm Shasendu. I work for Apple in a product-oriented research team called Imaging and Applications. So, like I think anything from like photos or cameras that has been like developed by my team. Yeah, before that I used to be a grad student at CMU Good afternoon, everyone. I'm Amay. I'm a machine learning engineer at Optomatics. I work on building AI systems in home delivery pharmacies. So we work on automating pharmacy with helping in increasing the accuracy, reliability, and also the fulfillment times for our customers. So I'm happy to be here and share my insights.
Thank you, guys. So I think we're just beginning this session with understanding the history of computer vision. I think that will be helpful for a lot of people in the audience. Now, computer vision has evolved. In good old days, there used to be a lot of steerable filters, then we moved into convolutional neural networks, then we moved into transformer models, and then now we are moving into multi-mode transformer models. Models have increased in sizes from being hundreds of parameters to be billions of parameters. So maybe I'll start with Shumend. And given Shumend, your background in retail analytics, so how has classic computer vision evolved from when you started all the way to the deep learning era and into today's one, especially for things like integration loss prevention, customer analytics. So how has it evolved?
Right. I have been working in the computer vision space from 2014, just when deep learning got started. So we're using very common computer vision algorithms like GANI and watershed or something like that, wherein you could just put some kind of rules and if you have some pattern specific to the rules, only then it would work, and it would never work apart from that. You would put some kind of a threshold. I think this is when deep learning came into picture, where you could identify different patterns like a dog, cat, etc. Right? So applying that into products, so 7-Eleven has like huge SKUs, close to like 20,000 SKUs. SKUs meaning 20,000 different items that's sold in the store, right? So how do you identify these, and then what are the potential advantages of that? For example, in the checkout system, there are like different form factors, try to use computer vision to solve those problems. This is how deep learning evolved, and then it was first training models, and then slowly going to like zero-shot learning. How do you solve problems without training models, with lower models, or sometimes no models, and now getting into Gen AI space wherein the cost is so low that you get charged only by the API call. So this is the journey that I've seen in the last 5-6 years.
Krishnendu, Apple is very big on device machine learning these days, and this ranges from doing next token prediction as you're writing your SMS or iMessage, all the way to illuminating a picture that has been taken in a low light condition. So there's a lot of machine learning that Apple is utilizing on a device constraint, on an energy constrained device. So from your on-device experience, again, how has that classic lightweight sort of model evolved into models that not only take into account vision, but also text, etc., on an on-device setting?
Yeah, I think classical computer vision algorithms are still used and in like a lot of places, specifically like edge contour detection
Like they are specifically used for like camera autofocus or like video stabilization, these kind of things. Also, classical computer vision methods offer like a very graceful fallback when the device is kind of busy doing something else. Like most of these algorithms are currently processed in like Google or they are mostly like processed on specific hardware, like or AEs or GPUs. So they are like busy. These also like offer like a very graceful like fallback also. Also, like from a product point of view, a lot of these devices are dependent on the kind of hardware that they have. So, like let's say maybe like an iPhone from 2020, and it has supported you. It will just focus on like person only, but then it has evolved into like a lot of different things in like the current iteration of the phone. And so like utilizing these conventional classical methods is also very helpful in like complex AI systems too, as an input, because a lot of these images are kind of being processed using these methods, and then they are processed using like complex algorithms. So yeah, I mean there is a definite shift from these methods to like the current data-driven methods we are using. But it's still
So maybe I think shifting the focus, let's say, from very retail-oriented company like 7-Eleven, on-device, machine learning, now all the way to a regulated industry, very much similar to JP Morgan, who is very, very regulated in whatever we do. And I'm imagining the same sort of constraints are there in the healthcare industry. So from your point of view, how has the traditional CV evolved? Do you still use it? If not, how do you put together a system that we, as a customer of companies like Optum, can say that we are getting the best of the breed?
Right. So classical computer vision techniques, as Siddhanshu and Sumek mentioned, are crucial piece. Even it's the same for us as well. So very specific problems, like problems where you want to solve for explainability, reliability, and transparency. These sort of scenarios is where traditional techniques still excel. Also, when it comes to time complexities, most traditional methods have linear time complexities compared to quadratic or exponential time complexities in the recent attention-based architectures. So this makes it ideal for us to use it in real-time systems where latency is a requirement. So it sort of becomes a no-brainer to try it out in situations where you want real-time high throughput solutions. A couple of other places where we value it is where we have space and budget constraints. So most industrial settings, you are equipped with cameras and microcontrollers. So there is no GPU access or cloud compute available. So sort of you then are pigeonholed into trying out traditional methods first and seeing if they work for you. So situations, it just depends on what use case you are using, but I still feel like traditional methods have their place.
Sounds good. Now, when we talk about the leap from classical computer vision all the way to transformers and multimodal algorithms, cost is a big thing because there aren't a lot of companies who can throw in millions of dollars to train these super large models, right? So maybe I think Shushendu, question to you is, at Apple, what's your approach in balancing cost constraints versus training these super large models? Because it comes with a price. How do you imagine when you're working in a project, trading off one versus the other?
I think cost constraint is something that is only considered for the inference. A lot of times, I don't think Apple has. But I think the is considering how we can run these things on devices, and there are like a lot of solutions for it. Of course, like there's the AAD, which is just designed to make these matrix computations way faster than a CPU or a GPU can do in less amount of time. And things are definitely like progressing on that, and like there are other companies which are developing on the same front. Additionally, there are tools like called courtroom, which offers like it is basically like a bridge between your model and how to harness the whole hardware ecosystem that Apple offers. So it contains a lot of different techniques for model compression, like normalization, tuning, these kind of things, and also it has adaptive, like dynamic protocols or like rules which kind of route these model layers to either like CPUs, GPUs, or AAs. That helps a lot. Also, like there's it all operates like on a unified memory. So like GPU, CPU, they all occupy the same memory bus. So there's not like a lot of time that is spent on copying things from here to there. So yeah, I mean like these things like really help to run things on device, but running like a whole LLM, I think even now with all these things, and yeah, people are making developments on like this security. So looking forward to it.
So when you coming back to your instrument, like retail is a very cost-sensitive industry, right? So how do you think about like if you are going into places like cashierless store, etc. How are you trading off cost versus the ROI of the AI that you are manufacturing?
Right. So, for sure, cost plays a very big role for us. We can't really like tons of GPUs because you do have constraints, especially when you're dealing with stores. You have like connectivity issues and things like that. Within these constraints, you have to come up with a solution. So, classical solutions are the best because sometimes you have to run at 30 frames per second, and if you go with